What is electronegativity? Electronegativity is a measure of the tendency of an atom to attract electrons towards itself in a molecule or compound. Electronegativity, nothing but a relative value of an element that describes its ability to compete for electrons with other atoms to which it is bonded. Since it is relative, it does not have any unit. Different factors affecting electronegativity of an atom are: number 1, atomic size or radius. Electronegativity of a bonded atom decreases with increase in its size. Shielding effect is directly proportional to atomic size, therefore electronegativity increases with decrease in shielding effect. Number 2, effective nuclear charge. When effective nuclear charge is high, the nucleus will attract the shared electrons with greater strength and the electronegativity will be high. Number 3, hybridization state of an atom. Electronegativity increases with increase in the s character of the hybrid orbital. This happens because the s orbital is nearer to the nucleus and thus feels greater attraction, resulting in increase in electronegativity. Number 4, bond order. The number of covalent bonds present between two bonded atoms is known as bond order. With increase in the bond order, the bond distance decreases, effective nuclear charge increases, and therefore electronegativity increases. The increasing order of electronegativity is single bondless, then double bondless, then triple bond. Number 5, oxidation number. The electronegativity value increases with the increase in oxidation number because the radius of an atom decreases with increase in its oxidation number. For example, the order of electronegativity for 3 oxidation states of iron is as follows: Fe3 plus greater than Fe2 plus greater than Fe. Please note that electronegativity does not depend on stability of fully filled or half-filled orbitals because it is simply the capacity of the nucleus to attract electrons. Here the electrons do not enter the orbit of an atom. Now let's learn about the periodic trends of electronegativity. Atomic size decreases on going from left to right in a period, therefore electronegativity increases. In a period, the electronegativity value of a halogen is maximum, while the electronegativity value of an alkali metal is minimum. For example, oxygen is more electronegative than nitrogen. Due to its higher atomic number than nitrogen, oxygen has more electrons, which results in stronger attractive force from the oxygen's nucleus for a bonding pair of electrons than that of nitrogen's nucleus. Atomic size increases on going from top to bottom in a group, therefore electronegativity decreases. For example, oxygen has higher electronegativity than sulfur. Oxygen has a smaller atomic radius, the bonding electrons are closer to the nucleus and therefore it exerts a stronger pull. Bonding electrons as sulfur are farther away and its nucleus, and therefore it exerts a weaker force. Also, there is one layer of shielding electrons in oxygen, whereas in sulfur there are 2 layers. The electronegativity value of inert gases is 0 because they do not form any covalent bond. There are several exceptions to the general trend of electronegativity we just learned. Number 1, the element of group 2b, that is zinc, cadmium and mercury, show increase in electronegativity value on going from top to bottom in the group. Number 2, the elements of group 3a, which is aluminium to gallium, show increase in electronegativity value on going from top to bottom in the group. Number 3, the elements of group 4a show no change in electronegativity value on going from top to bottom in the group from silicon onwards. Measurement of electronegativity. Pauling scale. Linus Pauling was the first scientist to put forward the concept of electronegativity and created a scale to measure it. Fluorine is the most electronegative element with an assigned a value of 4.0, and electronegativity values range down to scacium, cesium and francium, which are the least electronegative elements at 0.7. The electronegativity value for other elements is calculated using the formula Xa minus Xb equal to 0.208 into the square root of delta, where Xa and Xb are electronegativity values of element A and B, and delta is calculated using following formula. Mulliken scale. Mulligan suggested that the value of electronegativity of an element should be expressed as an average of the values of the ionization potential and the electron affinity of the element. Also, electronegativity given by Pauling scale xp is equal to 0.336 into xm minus 0.615, where xm is electronegativity given by Mulligan scale. This brings us to the end of our video on electronegativity.
Please like, share and comment on the video, and don't forget to subscribe to our YouTube channel for more interesting and educational videos to earn